Welcome back to Intro to iOS Development. Today is our 6th lecture, and this is going to be part 1 of our lectures on networking. So before we start with new material, just some logistics to go over. Just a reminder that if you want an extension on a project, we're pretty lenient in granting them, but our requirement is that you ask for them at least 24 hours in advance of the project's due date. So for a project that's due on Sunday night, you should ideally ask for it before Saturday night. And we do sometimes give leniency on this, but please try to make sure they're requested at least 24 hours in advance. You should also have grades for projects 1 and 2 on CMS now, and we're working on projects 3 and 4. And then the new office hours spreadsheet is up. It's linked on Piazza, but it's the same spreadsheet as we've been using for the past 2 weeks, just on a new sheet. And now some review of Lecture 5. The first question is, what is one reason you would want to use a UI collection view over a UI table view? And then I'll give you guys a minute to kind of read through the options. Cool. So the answer is C. You should use a UI collection view over a UI table view when you want to scroll in both directions, or use a grid layout like an Instagram profile feed. The next question, how do you set the spacing of a UI collection view? And I'll give you guys a couple seconds again. So the answer is C. You can't directly set the spacing of a collection view like you would for a table view. You need to set the spacing of the UI collection view flow layout. Cool, so moving on to our new material, networking. So networking basically deals with connecting your app to the internet. And why would we want to connect our apps to the internet? So, for example, imagine you're developing an app that's a Facebook feed. You can imagine you have these posts that are your objects or your models, and then each one has like a title, a number of likes, a number of comments, and somehow you translate that into your app. So, how would we achieve this sort of infinite scrolling list? With what we know so far, we would create a post model like I mentioned. You'd have an array of post objects, and then use a table view or collection view with the array of post objects as your data source. So this should all sound pretty familiar. But let's think about what happens if like the number of likes on a post is updated, or a user deletes a post, or if users like new posts are constantly being added. You'd have to manually go into your source code, make the changes, and then rerun the app in order to get any sort of these like tiny little events to update on your screen. So what if instead your app was able to retrieve information from some database on the internet that was updated every minute or so? That would make your life a lot easier because you don't have to go into your Xcode project, update the code, make the changes, and then if your app was on the App Store, you'd have to like resubmit your app to the App Store in order for those changes to be made. So now that we see the advantages of connecting our app to the internet for like data, how do you connect your app to the internet? We do this by making HTTP requests. And these requests are a form of communication between clients and servers. And in iOS development like we're doing, your app that you're developing is the client, and the server is just, we'll say, somewhere on the internet, and the server will hold some data that you want. So there's a couple types of HTTP requests. The first one is probably the most common and that you'll use the most, which is a GET request. There's also something called a POST request, a DELETE request, and there's many, many more. But in short, what these three do, a GET request is used to retrieve or get data from the server. So going back to that Facebook example, if we wanted to get a post from the internet, we would use a GET request. A POST request is used to send data to the server in order to update or create some model in the database. So if a user created a new Facebook post, we would send that over to the server using a post request. And then the third type is a delete request, and this is used to tell the server to delete some models. So if a user deleted a Facebook post, we would communicate this to the server using a delete request. And now we're going to talk briefly about JSON, which is JavaScript Object Notation. JSONs have key value pairs like dictionaries. The keys are always strings, and the values can be strings, objects, numbers, booleans, arrays of any of those previous values, or null. So when we mentioned that they're like dictionaries, if you were to print a whole JSON out, it would look like a dictionary. So here's an example. We have one JSON object that has a name, a number, and an array of instructors, which are strings. So you see this kind of looks like a dictionary with the key on the left side of the colon and the value on the right side of the colon. So why do we care about JSON? We care about JSON because servers often send data back to us in JSON format. So we need to know how to interpret JSON in order to display the data accordingly. And now, this seems like a lot of work, right? So there's actually external libraries that we can use in order to help us write our code for networking. So external libraries are going to help you save a lot of time by allowing you to use code that's written and provided to us by other developers. So just like in this example, we're trying to accomplish a task of networking. There's a lot of tasks that developers often find themselves having to write code for that others have already written before. So if this code is open source in some external library, we can use them to help us save time. So CocoaPods is an external dependency or library manager for Swift and Objective-C. CocoaPods houses over 45,000 libraries that are currently in use in over 3 million apps, and it provides an easy way to manage, download, and use third-party libraries. If you're still a little confused about what this means, it's a little similar to pip for Python and npm for Node.js, or if those analogies don't make sense, you can think of it as, let's say I've written some code that does some really cool thing, and I've put it in a library, and now I've uploaded it, not necessarily uploaded it, but I've added it to CocoaPods so that other people can download it and use it within their apps. So in AppDev's apps, we actually use these pretty extensively. In Eatery, we use a CocoaPod called Hero Animation Library that allows us to achieve some cool animations. In Ithaca Transit, we use the Google Maps library in order to have that nice map on the background. So in order to use CocoaPods, you first have to download CocoaPods, which you'll do with sudo gem install CocoaPods, and then that just downloads CocoaPods onto your computer as a whole. And then to install CocoaPods within your project, inside the folder with your project in it, you'll run the command pod init, and that will create a pod file. So we're going to go over this very briefly right now in the slides, but then we'll do it again in the demo so it makes more concrete sense. And then, like I mentioned before, when you run pod init, it'll create a pod file, and this is an example of a pod file. You'll see under the comment pods for clicker, I have pod Alamo Fire, pod Crashlytics, pod Fabric, and so on. And these are all the pods or libraries that I'm installing into my project. So we'll use the terms library, dependency, and pod interchangeably, but CocoaPods refers to them as pods. So once you've added all the pods into your pod file, you'll run the command pod install, which will install all of the libraries into your project and create a .xc workspace file out of your .xcode proj file. And then in order to use the libraries, you must work in the .xc workspace file from then on. And once you start working in the .xc workspace file, you never want to go back to working in the Xcode proj file. Cool, so There's a lot of information, so we're going to move on to the demo. And what we'll be doing in this demo is we have this JSON that is hosted somewhere on the internet, and we're going to convert it into a table view on our end, or on our simulator. So this demo is actually divided into 2 parts. And for this week, we'll go over how to install CocoaPods and set up a pod file inside your project, and then we'll work on retrieving the data from the internet and just printing it into our console. And then next week, we'll work on how to translate the JSON into actual table view cells. So if you guys have downloaded the code from the website, there is starter code. And then we just move it into a location on your computer that you're familiar with. So like you can see, I've downloaded it and moved it into my desktop into this folder called iOS course, and here's my zip file. Then I'm just gonna unzip it and then just open the .xcode proj file first. Okay, so you'll see that inside our view controller, we have a table view. So that's the table view that we're going to use to display the courses eventually. An array of courses with the course model that we've already created. And then just setting up the table view, setting up constraints. And then here's the function that we're going to be concerned with today, making a call to the internet to load our shopping cart of courses. And then just as a side note, right now there's nothing inside UI table view delegate because we're not actually going to be setting up the table view in this part of the demo. And you don't get any errors because the methods of UI table view delegate are all optional. But ideally you would want to put something like did select row at inside this extension. But for now, we're going to disregard that. So now if you take a look at the file hierarchy, you'll see we have this like new sort of file, which is Network Manager. So a really good practice to follow is to put all of your networking code inside a Network Manager file. And you'll see in this file, we have just one endpoint. So let's just take a look at that endpoint. So this is the JSON that we want to retrieve, and shout out to one of our past instructors for hosting this on her website. But yeah, you'll see we have this JSON that has a data object that maps to a classes object that then maps to an array of classes or courses. So this is the data we're going to want to retrieve from the internet today. And you'll see we use the word endpoint. Basically, any sort of route or a server will normally have multiple endpoints that you can access to get different kinds of data. So this one just retrieves classes. I could have another one that retrieved the status of a certain class, like whether it was open or closed. But that's just the terminology of endpoint. So now we'll move on to installing CocoaPods in our project. So looking back at my Finder, you'll want to open your terminal. So you can just do Command space to bring up the search bar and do your terminal. I have a different one that I'm going to use, but your normal terminal should be fine. And what you'll want to do is go into the directory where you have this project saved. So, for example, mine is in desktop, iOS course, L6 starter. So you want to go into this directory, the one that has the .xcode proj file. So in order to do that with a command, you would do cd desktop, iOS course, L6 starter, and then if you want to check that you're in the right directory, you can just run the command ls, which will list all the files in that directory. So yep, I can double check that the Xcode proj file is inside this directory, and that's where I want to be. Another thing that you can do, I'm just going to do cd ... to go back all the way. If you don't want to type out your entire path, you can do cd and then drag this folder into your terminal, which will kind of copy that path, and press enter. And then if I ls again to check, we'll see that I'm in the right spot. So I'll give you guys a couple seconds. So these are just two options for how to get into the right directory, either by manually typing it out or by drag and dropping the correct folder. And then running ls as kind of like a sanity check to make sure you're in the right directory. Cool. So the next thing we want to do is pod init. And what this will do will create your pod file. And you'll see over here, this pod file got created. Cool. So you can just open your pod file with a text editor. I don't know why it wants to open it with that, but we'll just go with Sublime. And then you'll see that, like the example pod file in the lecture slides, we have pods for L6 starter, which is the name of my project. And here's where I'm going to do pod Alamo Fire, because Alamo Fire is the name of the library or pod that we're going to be using for networking. And then once you're done with that, just save the file, and then you can close it. Leave it up for one more second. And then once you've saved it, you can go back to your terminal, and then you want to run pod install. And if that was successful, you should see installing Alamo Fire. And then you'll see you get that warning. Please close any current Xcode sessions and use l6starter.xc workspace for this project from now on. So what I'm going to do is I'm going to go to Xcode and I'm going to close the Xcode project that I have open. And if I go back to my Finder, we'll see that in addition to the files that I had before, I now have an XC workspace, which is what I want to open in Xcode now. And you'll see that this has all of the code that was there before. And in addition to the code that was there before, there's this new thing called pods that has Alamo Fire, so that way you can use it. And if you were to open the Xcode proj file again, you wouldn't have Alamo Fire there. Okay, so just to kind of go over those steps one more time, what you want to do is first cd into the correct directory, either by typing out the path or drag and dropping the folder. And then ls just to double check that you are in the directory that has the Xcode proj file. Then run pod init, which will create a pod file for you. Oh, it did open in TextEdit. Cool. Let's make that bigger. Create pod file and then add this line of code or line of text, pod Alamo Fire, under the comment pods for L6 starter. Save that, and then once you've done that, you want to run pod install, and if everything works as expected, you should see an XC workspace file was generated, and you'll want to double click or just open that. So if you guys have any questions or any problems with CocoaPods, totally understandable. It's a little tricky and sometimes hard to just install in the first place. just ask questions on Piazza with any like relevant screenshots that might help us debug the problem for you. So now moving on to actually retrieving this data that we want. All of this code goes inside Network Manager, which is where we're going to do our network calls. So first I need to declare my Network Manager class since I don't have like the class anywhere yet. So class Network Manager. And then this is where I'm going to add my functions to get the courses. So because we're going to be calling this function on not necessarily an instance of a network manager, we're going to make this a static function. So static func get courses. I'll make sure to kind of explain that a little bit more when we go on to the next step of actually calling this function. But for now, just remember that you want your network manager functions to be static functions. And now we need to import Alamo Fire so that we can use it. So that goes up at the top of your file. You just import Alamo Fire. And then if that doesn't pop up for you, so like when I did that, I had I just typed AL and Alamo Fire came up. If that doesn't come up for you, try first closing your Xcode project or your Xcode workspace and reopening it, or just try going to product clean build folder and then product build again, because sometimes it doesn't register that you've installed Alamo Fires as a pod in your workspace yet. Cool. So now that we have Alamo Fire, I'm going to use one of its functions to make my network call. So in order to use an Alamo Fire function, you just do Alamo Fire dot, and then you'll have some gibberish, but you'll be able to use any functions that it has. So we'll see that I want to use this one called AlamoFire.request, and I'm going to use the third option that pops up for me. And then the URL is the URL that I want to hit on the internet, which is the URL we have saved in the variable endpoint. So for that argument, I'm going to pass endpoint. And then the method, we'll see HTTP method, which is what we were discussing earlier in the lecture slides. So HTTP method is actually an enum, so I can do dot, and then we'll see I have a ton of options. And because I'm retrieving data from the server, I'm going to do a get. And then we have no parameters encoding or headers, so you guys can actually just delete those for now. Cool. So we have an Alamo Fire request. And you'll see that the summary is kind of convoluted, but basically it creates a data request to retrieve the contents at the specified URL. So because I deleted those, they're just going to use all these default things here, which is fine for our simple get request. And then this will make a request, and I don't know if it says the return type. Yeah, so it returns a data request, and what we want to do is we want to validate that request and make sure like it was a valid request. So I'm going to do dot validate, and then I'm going to do dot response JSON because the server is going to be returning a JSON. Now we have this kind of funny looking syntax, and if you guys did the closures extra credit, this is what that was. You'll see that it's looking for a data response any, and then points an arrow to void. So it looks like a function type, which it is. If you press enter one more time, so just do that again. If you click on data response any and get it highlighted, or you can double click to get like this new sort of format, or you can press enter. Basically, response JSON is going to go all the way to the internet, communicate with the server, and get back data, which could potentially take a really long time. So what a closure allows you to do is, once that response comes back, you store it inside the variable here, and then run the code after the in keyword. So I'm going to call this response. I'm going to get rid of the parentheses. And kind of just to reiterate that, response JSON has to fetch information from the internet, and it could take a really long time to come back to us, so we don't want to kind of just stall here forever, and instead we want to free our app to do whatever else it may be doing. And then once the response does come back, we're kind of capturing it in this variable called response, and then we'll be able to run any code that we write here with that response after it comes back to us. So here's the code to kind of retrieve the JSON out of the response. So first, a response could be successful or unsuccessful. So we're going to do a switch on the response's result. And just to kind of elaborate or kind of give a better example of why we're doing this switch, I'm just going to give you guys an example of what a data response looks like. So it's an enum. I'm just going to call mine example data response. Type T of any. So don't worry too much about this syntax here, but basically a data response has two cases. A success that carries some data of type T, and a failure case that carries an error. So that's what this response, the type of this response object looks like. So I'm going to switch on the result, and I want to have two separate cases, a case for when there was a success, and you'll see that it automatically populates of type any, which is this data object. So I can just do let data to be able to refer to that. And then for now, I'm going to ignore what goes on in there. And then we have the failure case. And once again, we have the type error, and I can kind of capture that error in a variable just by let error. Now, let's do the failure case first. You can just do print error. So in the case that my request fails and the result is a failure, it'll come here, capture the error, and then I'm printing it. And then we're going to do something similar for the success case. And since today we're just going to be printing the success or the data into our console, we're not actually displaying it on the simulator screen, I'm just going to do print data for today. And then once again, what that will do is take the data inside the response and print it out in the case of a success. Cool. So now we've written this function and we actually want to call it. So we're going back to our view controller file, and you'll see we already have this function header, func get courses. How do we make a call to the internet now? So we've written our function inside Network Manager. What we're going to do is just do Network Manager dot get courses. And then this is why a static function was important. Since I'm calling this function directly on the class, it has to be static. And then we'll just remove static for a second and go back and build this. You'll see that instance member get courses cannot be used on type Network Manager. Did you mean to use a value of this type instead? So basically, when we don't do that static keyword, it by default becomes an instance method, which means it must be called on an instance of Network Manager and not just the class itself. So basically that means in order to use it this way, I'd have to do let network manager equal network manager like that, and then call it on my instance of network manager that I've created. So to avoid having to do that, since, oh, I spelled that wrong. To avoid having to do that, which isn't really necessary since we don't need an instance of it in order to call the method, we create this as a static function, and then we can just do network manager, the class, dot get courses. So now if I build that, it should be able to run. And then you'll see we've already called get courses inside view.did_load. So if I run this on the simulator, it'll call get courses, which will call network manager.getCourses. Cool. So we won't see anything except for the title up here. But we'll see that inside the console on the bottom, we've printed out the JSON that was over here at this URL. So that is the basics of making a network request. Just one cool or kind of tool for debugging. You can add breakpoints to your code to understand like the flow of stuff. So I'm gonna add a breakpoint just by hovering over the line numbers and pressing on it, and this blue like flag will come up. So what I expect to happen is get courses will be called, and then once your app runs into a breakpoint in the simulator when you're running it, it'll stop and freeze, which is how we can kind of supplement our understanding of what's happening, or if something's going wrong in your code, try to figure out where it's going wrong. But basically, I expect it to call get courses, and then I expect get courses to call network managers get courses. So inside network managers get courses, I'm going to put a breakpoint. And then because like my internet connection is working, I'm pretty sure I'll have a success, so I'm going to put a breakpoint where the success case is. So now if I run this again, you'll see we have a breakpoint on get courses, which is good because I expected that to happen. Next, I expect it to go into network manager. So right now your app is like frozen, like, oops, like you can't do anything. In order to get it to resume, you want to push this third icon over here, which says continue program execution. And yep, that's what happened. It called network managers get courses. And then if I do it again, oh, I don't know why it broke there. It broke there because like it got the response back. And now we're printing the data. And then if I resume a final time, I have the data back printed into the console. Cool. I don't know if turning off my internet connection will make this stop working, but we can try. And then in this case, I'll get an error. Yeah, so breakpointing at get courses, breakpointing when I'm calling get courses, switching on the response. Oh, we still got a response. Interesting. Yeah. I don't know how to fake an error. It might have been like cached by Alamofire, which is why I was able to get this back. But breakpoints are a really cool tool, and if you click on them again, they'll just disable them, and if you right click, you can delete them. But that kind of wraps up our demo for the first part of networking, and then next week we will go into how we like convert this one instance inside the JSON into a course. You'll see that our course actually matches this we have a name and a name, a code and a code, an instructor and an instructor, and this boolean enrolled. So we're going to be translating all of these into course objects and then putting them inside our table view in the next demo. Cool. So going back into our slides, just one final thing. We have an extra credit assignment for this week, so there's no mandatory assignment for you guys to do, but it's on the closures. It's on closures, and it's a playground format like Project 1 was, so you won't be working in Xcode and building an app. Instead, you'll just be working in a playground, and this is due the coming Sunday, April 26th at 11:59 p.m. Eastern Time. And closures are that thing that I talked about inside the network manager. Just to go back. Closures are this kind of strange syntax where you have something in and then some more code. So if you guys want to better understand that, which will be really helpful for networking, I recommend at least taking a look at this assignment. Besides that, that's all for today's lecture. I hope you guys are doing well and your families are all doing well.